So my name is Rajas Karandikar, and I am the Group Sales Director for CloudCover. CloudCover is an AWS partner, and I'm thrilled to be here speaking to you, all of you today. Um, what I'm going to be talking about, since we were very excited when we were asked to present at the startup track, because we work with a lot of startups across the region. So what I'm going to talk about today is what are some of the common technical challenges that we've actually seen startups that we work with face, and of course how we've solved them through some real world examples, right? So, um, so the agenda for today is a brief introduction about CloudCover, who we are, what we do, and then we're going to dive straight into what the challenges are, the 5 challenges, along with the associated solutions, right? So just one slide about us. We are a cloud consulting company. We are focused on automation and scale. The logos at the bottom actually represent things that we believe in. So I'll only talk about the automation piece, right? We have a belief in our company that if you do something twice, you have repeated it one too many times already, which means that you automate as much as you can, and you let machines do the job, and leave out manual intervention as much as possible. But why we're here today is because we've worked with startups of all sizes and all shapes across India, across Southeast Asia. And we've also had the privilege of working with 5 unicorn startups in this region as well. So we've really seen many startups go from the journey of founding a company, starting up a product or service, scaling it, tackling challenges along the way, and then making it really big and then scaling to maybe millions or multiple millions of users. The challenges that we've seen startups take along the journey um, are, we're going to focus on these 5, right? And these are mainly technical challenges. I'm not going to talk about business challenges today. But if you look at these challenges, you know, they reflect problems that you face along different stages of the startup journey. So when you're just getting started, how do you experiment for as low a cost as possible? How do you may have a lot of ideas, right? How do you try them out for free? Once those ideas take some root and you find some traction, how do you now ensure that your first users of your product or your service have a consistent and a reliable experience? How do you then respond to the changing demands of the market? How do you respond to what users need from your product or service? How do you now quickly iterate and build new features that your customers would appreciate? And then as you scale slowly, how do you now, with a whole lot of features on the platform that you have, your product or service, how do you still keep the service lightning fast so that your users all have a great experience? And finally, how do you make sure all these problems are solved at a much higher scale than what you started off with? So those are the 5 that we're going to focus on today. So let's look at the first one, right? How do you innovate at a very low cost? Right, this statement applies to enterprises as well as to startups. The more you want to try ideas out, right? The higher typically your cost might get, right? But if you want to enable innovation, right? If you want to increase experimentation, you have to figure out a way to keep costs low and lower the cost of failure. So what we've seen startups do, and when we've worked with startups, one of the key recommendations that we make is use serverless architectures to test your hypotheses for almost $0. What do I mean by that, right? Um, Look, an idea is easy, right? It's getting started on AWS is incredibly easy. All you need is an idea and a credit card, right? And off you go. However, an idea costs nothing, but servers cost money, right? Um, when you build serverless architectures, and I'm talking about services like Lambda or DynamoDB, which inherently are serverless, they're very easy to use and easy to configure. AWS has done an incredible job of making them extremely developer friendly and extremely easy to use, right? So you can very quickly and easily get started on serverless technology to test out your ideas and to experiment with multiple products or features that you might be working on. And the best thing is, all the heavy lifting that needs to be done is taken care of by AWS. Now, take the example of EC2 versus Lambda. While a lot of the heavy lifting around the physical infrastructure is taken care of by AWS, if you have an EC2 instance, there's a little bit more operational overload or operational work that you have to do in making sure that instance is up and running. If it fails, you have to restart it, so on and so forth. If you're running on Lambda, even that management is done by AWS. So it's extremely easy to use, and it allows you to focus on your product or on your service without having to worry about infrastructure. And one of the startups or one of the companies we did it for was for Ducati out of Thailand. Now, Ducati is not exactly a startup, but their Thailand business operates very much like a startup. It's a pretty small business. They wanted to try out an idea where you could book a day at the track. It's called a track day, where you could take your Ducati, book a track, and actually race your Ducati on a proper racing track. Now, this was an idea that they wanted to test out and they wanted to implement. But they didn't, when they came to us, they said, we don't want to pay a very high cost for this because we don't know how well it's going to scale. We don't know if it's going to have any traction in the market. So we built a fully serverless platform for them using S3, DynamoDB, Lambda, and also the API gateway. Again, all of these are serverless technologies, right? We didn't have any EC2 in there. When we built that e-commerce website, they actually ran it for 3 months. And they had 15,000 visits, and they had close to 1,800 order bookings. And for those 3 months that they ran this platform in production with live users, the cost that they paid to AWS for those 3 months was $5.76. That's less than $2 a month. That's less than the price of a coffee, right? So using serverless technologies is incredible because it's easy to use, easy to configure, but it's extremely cheap. And our recommendation is use serverless as much as you can to test out and try out your ideas. The second component, let's imagine you have now taken your product and your service and you have implemented it, hopefully at a very low cost. And now you're getting your first users on the platform. Now, what you want to do is you want to make sure that the first users that you get have an incredible experience on your platform. You provide them with a consistent and a reliable service. As these are the users who are going to give ratings to your product or service. These are the users who are going to talk about your product or service out in the market, right? It's on the back of these users that you're going to scale. So you want to give them the best possible and the most reliable experience. So Werner Vogel's CEO of Amazon says this, everything fails all the time. What this means is when you architect solutions or when you architect your product or your service on AWS, think of all possible failure scenarios and take those into account when you're designing your service, right? So our recommendation is seek and destroy all possible single points of failure in your architecture. This is the time to do it. As your products start to just gain traction in the market, you must make sure that the reliability of that service is top-notch, right? And the only way to do it is go over your architecture, identify single points of failure. What are single points of failure? If there's a component that fails and takes down your entire application or your entire product or your service, that's a single point of failure. So seek and destroy, right? If you find a single point of failure, it means that don't try to bypass it. Don't try to engineer around it. Try to re-architect it. Make sure it doesn't exist in your architecture. Because if you allow multiple single points of failures in your architectures, eventually that's going to build into engineering debt, which you're going to have to pay off at some point. We're going to talk about this in a bit. Remember, humans are also single points of failure, right? If you have a great developer who's building fantastic code, but they're the only ones who know how to build it and how it runs, that's a single point of failure. So we often get called into situations where we're asked to optimize platforms or make them more performant or get them to be more reliable. And when we ask our customers to describe their platform or to share any documentation, architecture diagrams, network diagrams, anything, sometimes they don't have anything because the people who've built it have maybe left the company or maybe they're doing other things in the company, right? And no one wants to touch their architecture because everyone's too afraid that if they do something to it, it'll break, right? So they leave it running, right? So make sure you document, share across teams, right? We use Slack internally to share everything that we do in our development team and our DevOps team. The third advice here is try to use services that are inherently multinodal. What do I mean by that? Take S3 as an example. S3 as a service works across multiple availability zones inherently, right? So you don't have to do anything special to get higher availability or more reliability out of S3. It's reliable and available by default. So try to use services like that in your architecture. So we did this for a company, and I'm not going to name them. This is the only company that I'm not going to name because I'm not going to stand up here and name and shame someone that their architecture was bad, right? So we're going to keep this one anonymous. But this was a video ad platform that we started working with, right? And this was back in 2016, and this has significance because the services that AWS has today, some of them weren't available back in 2016, or maybe weren't as mature, right? So it was a different time. But inherently, they had a monolithic architecture where everything was on one server. The entire platform was on one server where they were using, instead of object storage, they were using a file server to store all all the video files. And they were using only one server to do all the processes and the permutations that needed to be done on those files. So when we came in, we had to move all the storage to S3, multinodal, right? We added SQS, simple queue service, right, to queue up the videos for encoding and transcoding. Again, multinodal, right? We had an auto-scaled worker pool. So rather than one server doing the job, we now have an auto-scaled group of servers doing the same thing. So every component of the architecture was now more reliable than it was before, right? So again, point number two, seek out single points of failure, improve reliability by re-architecting. Now let's say you've done that, right? So you now have a product or a service that has a few users and you've been able to provide them a good, reliable experience. You start getting feedback from the market. Those users are now telling you that, hey, I need more features, or I need your service to do X that it doesn't do for me today. Or if you have an iOS app, oh, I now need an Android application, right? And you're under pressure to deliver those features or those services or those iterations as fast as possible to the market. Because if you don't do it quickly, someone else will, right? So what our advice there is automate, right? That's the most powerful tool that you can enable your developers with, right? So you have to make sure that your developers are able to run in production or push features to production with the least amount of friction possible, right? And there are many ways of doing this, but our key recommendation is simply move your dev environment to the cloud. AWS has a lot of awesome features like code build or code deploy that make it super easy for you to run CI/CD pipelines on the cloud, right? We often get called in to say that development time or the time taken for a service to go from being just in development to being in full-fledged production is often quite high, and those delays are unacceptable to the business. And frankly, many of the startups, or most of the startups that we work with now have an automated CI/CD pipeline. It's par for the course, right? So one of the companies we did this for fairly recently is a startup out of India called Play Games, and they have a game called Rummy Circle, right? It's the game of Rummy, it's the card game. So not only did we migrate them from an on-premises data center onto AWS, so we migrated over 300 servers. But after the migration, we built an entire automated CI/CD pipeline for them, where those 300 servers with 40 load balancers, which have 10 different databases underneath and 70 different applications on top, the entire environment can be started or shut down in 10 minutes. That's how fast it is to deploy that entire environment, right? And while building this pipeline, right, we put in automation as well. We added in auto scaling, we added alarming, we added fault detection, so that all the instrumentation that you need to know as to what's happening inside your infrastructure is now baked in to your code when it hits production. So you don't have to do it separately. So that's what we saw at Rummy Circle. And after they migrated this one game, they're now building the new games directly on AWS, but using the same tool sets and the same pipelines that we have built for them. So you build a pipeline once, and it is inherently repeatable with obviously a few minor tweaks or additions or subtractions. Next thing here, when you are moving fast, right? When you're acquiring users, right? When you're developing features as fast as possible, you inevitably acquire some technical debt, right? That technical debt may be in the form of choosing the wrong technology, or it may be having the wrong architectures in place. And when you're making those decisions, you may not know that it's adding to your debt, but what you should know is that at some point you have to pay it back. How do you do that, right? At a certain scale, right? When you are now onboarding a lot many users, right? And you have to focus on performance. You have to make sure that your application or service is lightning fast. You have to unclog your application's arteries. How do you do that? First step, instrument everything. Log as much as you can. Measure whatever metrics or whatever things that can be measured, because what gets measured gets done. How do you decide? You may run an audit of your application or of your service, and there may be a long list of things for you that you can now make better in terms of performance. How do you decide how to prioritize? The equation is pretty simple. Look at how many times the service is called, multiply that by the time it takes for the service to execute, and order this in descending order. Take the most difficult ones first. Take the top ones first, right? Those are the ones to automate. And how do you improve performance? There's no easy answer here, right? You have to use engineering effort to pay back that engineering debt that has gathered over time, right? And where we get called in as CloudCover often is for companies like Shaadicom. This is a marriage portal. This is a large startup that operates out of India. So we got called in specifically to reduce their engineering debt. So we built, or they were using PHP, which they were transforming to Golang. So we assisted them and we worked with the engineers, and both our engineering team as well as their engineering team spent a sufficient amount of time, that engineering effort I talked about, to repay that engineering debt. But they're running about 1 billion transactions, and those billion transactions needed about 800 CPUs to execute. After this entire effort was complete, after that migration to Golang, and a lot of other things like putting in a CI/CD pipeline and place some of the stuff I talked about before, those same transactions are now being done by 27 CPUs. Look at the improvement in performance and also cost, right? Huge productivity gains, right? We also changed them to be completely based on microservices. We had more than 20 microservices deployed in the year. All of this required effort, not just from CloudCover, but also from their own team, right? So they had engineering debt built up, which they had to spend some effort and time to unroll and to make sure that their applications is very snappy and very fast. So along the journey, we talked about getting an idea, getting started at low cost, building a reliable service, making sure that your developers have the power to add new features with as fast as possible. And then at scale, making sure that your performance is top notch. And if you've done all those things, congratulations, you made it. Winter's here, right? If you're now sitting in front of the room and you're looking at this and saying, look, I've faced some of these problems or maybe all of these problems that I've put up on the screen, right? These problems compound at scale. At the scale, maybe at this point, you have millions of users on your platform. We certainly hope so. But you not only have millions of users, you may be providing them a mission critical service. You have employees whose livelihoods depend on you, right? So you go to take care of all those things, and it's difficult, right? If you're sitting on the Iron Throne, you made it to season 8, congratulations, right? You now have more problems than you started off with, right? So I've put up some problems, but you can imagine what problems you face, right? And keep them here, whether it's making sure that users are loyal to your service, or keep retaining employees by making sure that you continue using the best of breed technologies, or like keeping an eye on costs and not letting it go through the roof. Or you can pick your problem here. Unfortunately, we work with many very high-scale startups, some unicorn startups as well. There's no easy answer to this problem. There's no silver bullet. There's no one thing that you can do to solve all these problems, right? But one of the things that has worked for almost every single one of our customers at scale is automate everything, anything and everything. The more you automate, the more reliable your service becomes, the less dependent you are on manual processes and on humans, because obviously human beings can make errors. The second thing is you have to communicate and collaborate, right? Your company might be very big at that point where solutions are being discovered, right? New ways of doing things are happening, innovations happening, but it may be siloed. Like the more you communicate and the more you collaborate, you avoid those silos, right? And you avoid adding on to that technical debt. And the final thing I'm going to say here is, I am after all a sales guy, so I'm shamelessly plugging CloudCover. At that scale, you're probably very, very good at doing something. Maybe you're the best in the world at doing what you do, but you cannot be good at everything, right? So continue doing what you're good at, leave everything else to experts like us. lean on experts, seek help. There may be or improvement areas that you may not be aware about. Get an audit done. Talk to us. Happy to help in whatever way, shape, or form we can. And we've done this for Hook. Now, Hook is a Singapore company. They're an OTT platform. We've been working with them for 3 years now. And we manage their entire infrastructure on AWS. And this is a significant amount of infrastructure, right? They have 300 servers, more than 40 microservices, lots of auto-scaling groups and load balancers. But what we've done for them is some of the things I spoke about earlier. Instrumentation. We've added more than 2,500 CloudWatch alarms. This is integrated into Slack and email alerts, so that the moment anything bad happens, it's alert. Get alerted immediately, and a lot of those fixes are automated. We store about 27 terabytes of logs in S3 to make sure we understand what's happening. And the important figures here are the time that it took for Hook to deploy a new service has gone down from 7 days to less than 2 days. These are not features or incremental deployments. These are brand new services deployed, right? And the deployment window is now less than half an hour, right? So there's massive productivity gains that we've been able to work on for Hook, and they've been able to achieve by working with us. This was my last slide. I'm almost out of time. Thank you so much for having me over today.